State Council for Science and Technology, and was awarded the Inspiring Teacher Award from the Indian Express, India's leading English daily newspaper. He has worked on various research projects funded by the Government of India's Department of Science and Technology, Department of Atomic Energy, and the Ministry of Human Resource Development. He has guided 7 PhD students, and many students are actively working for their research under his guidance. Ashwini Kumar has published more than 150 referred research articles in various national and international journals and conference proceedings. His papers published published papers received about 3,500 citations. His H-index is 29 with I-10 index 75. He is actively involved in several scholarly services, an editorial board member for several, a few international journals such as Journal of Informational Knowledge Management, a world scientific publisher, International Journal of Applied Mathematics, Computer Science, Cybernetics and Information Technologies, and so many. He is a member and a distinguished speaker of the Association for Computing Machinery, ACM, a member of the Institute of Electrical and Electronics Engineers, and vice chair of the IEEE Task Force on Educational Data Mining. He is a distinguished speaker of ACM. He served as division leader, and later served as Dean of the School of Information Technology and Engineering at VIT Vellore. Thank you very much, Professor Ashwini Kumar, for accepting our invitation and for giving your consent to share wisdom in your research domain to our participants. With these words, I invite Professor Ashwini Kumar to deliver his talk.
Good afternoon, everyone. At the outset, I would like to thank Srinivas sir for giving me an opportunity to interact with the participants today under this flagship program of faculty development program. And it's my immense pleasure. And above that, it is an honor that I am delivering this talk, which in fact is guided by Srinivas sir when I was doing my PhD under his guidance. So in this regard, whatever today I am presenting, or today whatever the brief profile sir has read, is just because of the training, mentoring, and guiding. But because of all that, I'm able to get that profile. Thank you very much, sir, for giving me the opportunity. And yeah, so today afternoon, I'm going to talk about this data analysis using lattice theory. And before I start, I'm happy to note that there are about several participants across the country, both faculty members and as well as research scholars and students who have enrolled for this particular program. So, so it's a really good encouragement sign that many people are interested to know about that, and I hope that the next 1.5 hours would be some kind of a fruitful learning experience for everyone. So in that regard, I'll proceed with the talk. So my talk would be structured in this manner. I'll be giving a brief intro, very brief intro, followed by the lattice theory fundamentals. Considering the participants are all from mathematics and computer science background, I will spend little less time on these 2 points, but I would be focusing on the major technique that what we are going to address today, which is the formal concept analysis. And subsequently, how this analysis is providing 3 outputs. One is the concepts, then the lattice structure, then subsequently the attribute implications and association rules. How these 3 outputs we are deriving out of this analysis. Subsequently, I will be showing a case study. Then also I'll be touching about our research contributions in this particular area in the last couple of years, especially my research students. Most of the work is driven and done by my PhD and MTech research students. So applying this particular theory to various computer science applications. Then I will be showing a software or a toolkit which we have actually used called ConEXP, called the Concept Explorer. So that also I would be touching upon. So this would be the my focus. But another point is that my talk would be on providing a lot of the introduction to these aspects, and my talk would be not going to the details of these applications. I will not go into the details of the applications because each one is a research problem. So in that regard, you can expect that this talk would be providing a bird's eye view. So I just wanted to set the context to everyone. So this talk would be providing the bird's eye view of the formal concept analysis, its applications, and also about demonstrating with a tool kit, which is the Concept Explorer. So my talk would be based on this. Especially those who are really interested to go into each of these applications. I'm also going to show our the articles that we have published. It would be really interested. If those who are really interested, they can go to those articles and then have a look at it. So before I proceed, I just wanted to show this slide, which indicates what are all the various, the mathematical topics that generally students study or the faculty at the engineering institutes and the higher academic institutes teach. And I also try to map them to the computer science courses. Generally, there is this link is missing, especially in the computer science students. They think, the computer science is about writing the programs and developing the software. But fundamentally, one should understand that these are all rooted to the mathematics. And so you can see that discrete mathematics, the logic, the probability and statistics, linear algebra, and the calculus, number theory principles. So what everyone learn in their engineering programs or higher educational degrees, they're all rooted, linked with one or many computer science theories. So until and unless, as a student or as a scholar or as a sometimes even the faculty, we link both, I think the learning would not be complete. So I think we should keep this point in our mind and then proceed. And at this regard, I would like to also mention one of our experience. When way back to 2002, itself, Srinivas sir, when he was here in Vellore campus, he was very much insisting about using the MATLAB. At that time, many people have not realized the importance of MATLAB. And in our campus, we used to have a lab in our one of the building. So instead of mathematics department, Srinivas sir used to come there, sit with the one of professor there called Dr. Satish, and he used to explore the MATLAB. And many people could not understand why he was doing that. And subsequently, in 2009, I suppose, if I'm right, 2009 or 2010, the institute has taken a policy decision that to teach mathematics through MATLAB. So in fact, in that way, one should understand, the visionary thought process that's there with some of the intellectuals, and then, we move on under their direction. So in that regard, if you look at various mathematical principles are having very good link with computer science. So this slide, which I always show as my, the first few slides in my talk. Okay, so now, mathematics is one of the essentials, emanations of the human spirit, and it has linked with many disciplines. And this is one of the article published in ACM itself, talking about the role of mathematics in computer science. So those who are really interested can have a look at that. Now coming to the current scope of the talk, especially on the data analysis, data mining, big data, or now people talk about data science. We all know that the importance of data, and we all know about the importance of analyzing it, and above all that, there is a huge business potential that even the industry has realized. But the point is that as a student or as a scholar, when I want to do this or explore these domains, it is important that I need to understand what is the math behind these, the data analysis. So whether it is vector spaces, whether it is the matrices, whether it is the probability and stat, there is a lot of math behind it. So this one particular image I wish to show before I proceed. If you look at this slide, this is a beautiful slide from IBM, which I have derived. If you look at the whole spectrum of artificial intelligence, if we see here, there is artificial super intelligence, which we are all actually trying to work right from 1945, when Alan Turing has proposed the artificial intelligence to build a super intelligence machine. But the point is that we have not yet reached here. Now, the level below that is general artificial intelligence, which again, we are all still working towards achieving general artificial intelligence. But the point is, what we are all at is narrow artificial intelligence, in the sense that we have beautiful applications, beautiful algorithms, we have excellent sophisticated tools that are performing or that are doing good in a specific tasks. Say whether it is image processing, image recognition, performing video analysis, so playing the chess. These are all the intelligence engines that are doing specific intelligence tasks. So and hence it is regarded as narrow artificial intelligence. Now, point is, there is a recent revolution called, I think many of us, all of us have heard about the chat GPT, which people are calling that, it is above narrow artificial intelligence, because it is addressing or answering questions from many domains, and then even it is answering the creativity related tasks. So in that regard, it is just above the narrow artificial intelligence, but again, we cannot call it as the general artificial intelligence. Now, coming to narrow artificial intelligence, it has sub-disciplines like machine learning, which is further divided into supervised machine learning, semi-supervised machine learning, unsupervised machine learning, and reinforcement learning. Under that, if we, again, it's not that I'm going to touch all these things. Today I'm going to talk about finding out the associations in the data, which is association rule mining tasks. Of course, we have an algorithm called a priori algorithm, which is the most popular algorithm to find the association patterns in the data. But now, what we are going to talk today is another technique called formal concept analysis, or FCA, derived from lattice theory principles. I think I just narrowed down from a broad spectrum to a narrow problem or a narrow sub area where this particular technique is applied. I think this has set the context. Now we will move ahead. But before I proceed, under the machine learning, you have another beautiful, sophisticated sub-discipline called deep learning, which now has brought a lot of popularity and business applications, and which is driving force of current artificial intelligence. So that is another sub-discipline. So what is association rule mining, or for that matter, finding the associations? Now, imagine I have a set of transactions. These transactions could be any set of transactions probably happening at any marketplace. So imagine I have a set of transactions. How do I find the rules that will identify or predict the occurrence of an item based on occurrences of other items in the transaction? So that is my fundamental problem. How I am going to find the rules that will identify the occurrence of items based on the occurrences of other items. So take an example. Imagine we have these transactions from a market basket. Say take an example. One particular transaction says somebody has purchased bread and milk. Someone has purchased these set of items, say bread, diaper, beer, eggs. Another transaction says, that means you can imagine that one particular customer has purchased bread and milk, another customer has purchased bread, diaper, some beer, and then eggs. Another fellow has purchased these items, another customer has purchased these items. So these are all certain transactions that has happened. But the point is that we can identify from this set of transactions that whenever there was somebody purchased a diaper, he or she also has purchased the a beer. So because we can see that, wherever the diaper was purchased, you can also see that, beer was there. Okay, so this is one of the association. Now the point is that we can see that whenever the diaper is there, beer was there, there are about three such type of transactions. Similarly, whenever beer and bread, there is a milk, we can see that there are certain transactions that are there. So it is all about co-occurrences of the items, but it is not just, casually it has happened. So we will further proceed. We can see that certain fundamental definitions. What is an item set? An item set is a collection of one or more items. Say, take an example, milk, bread, diaper is an item set. A K item set means an item set that contains K number of items. Then similarly, we have another definition called support count, which says what is the frequency of occurrence of an item set. So take an example, milk, bread, diaper, this particular item set in the whole set of transactions is occurring two times. So that's the support count. Then what is support? Support means it is the fraction of transactions that are happening in an that contain in an item set. So take an example, bread, milk, and diaper. There are about 2 such transactions out of total 5 transactions of 5. So which is the support. Then frequent item set, then an item set whose support is greater than or equal to some minimum threshold value, which generally is set by the user depending on the application that what we have. But these are all some fundamental definitions that are there in the association rule mining. Then what is association rule? An association rule is generally expressed in the form X implies Y, where your set X and set Y are coming from your item sets. So take an example, milk and diaper is a set coming from your items, and also beer, which is also coming from the items. So this is an example for association rule. Now, how do I evaluate my rules? Again, it is based upon the metrics support as well as confidence. What is support? Which we have already discussed. It's a fraction of transactions that contain both your antecedent and precedence. Okay, so and antecedent and consequent. So that is X and Y. So from the rule, we are going to find out how many transactions. What is the fraction of transactions that are containing both X and Y is your support count, and then the confidence is going to measure how often the items in your consequent appearing in the transactions that are containing the antecedent. So this is about confidence. So there is an example for that from the given item set. So for the support and as well as the confidence. What is the association rule mining task? Given the set of transactions of T, the goal is to find the rule mining is to find all the rules that are having certain support threshold value, similarly certain confidence threshold value, which are generally defined by the user as per the application. It varies from application to the application. So this is the task that what we have, association rule mining task. Are there any algorithms to do this particular task? Of course, there are algorithms already available in the data mining literature called a priori algorithm, etc., for finding the association rules. What is the brute force approach is, they list all possible association rules, then compute the support and confidence for each rule. This is a brute force approach, but there are other algorithms such as a priori for finding the association rules. Okay, now we proceed to what is the current today's technique, which is the formal concept analysis. Basically, before I start the FCA, this is the theory is rooted to mathematical lattices, which are used in data analysis for the purpose of graphical organization, structural visualization of data analysis, and knowledge discovery. Further, it is also used for identifying the conceptual hierarchies that are there hidden in the data. So the lattice, mathematical lattices are used for these particular tasks in the data mining discipline. What is a concept? What is a lattice? In the data mining, we call it as a concept lattice, which is an ordered hierarchy, which is defined by binary relation. The classical case is a binary relation, but subsequently there is literature which has extended further towards fuzzy relations. Okay, now fuzzy relations. Then there are several other the data intervals are also there. So there are other things, but the point is fundamentally it is a binary relation between the objects and attributes in a given data set. What is the data set you call? The definition is called formal context, which of course we will be discussing it in a few minutes of time. All this entire theory is defined under the mathematical framework called formal concept analysis by two mathematicians, especially Rodolphe Willi and as well as Ganter in 1999, who are the base German scientists, mathematicians who brought this particular theory. I think I'll skip this slide, which is talking about what is a lattice, what is the partial ordering relationship, and what are the properties that it satisfies. This I will skip. Now, if you look at the data, we represent this data in the form of a table, which we are going to call it as the context or a formal context. That I will be talking about it. And also you can see that there are certain rows, there are certain columns, which we call them as objects, as the rows as objects and the columns as attributes. And you can see that wherever there is a relation between given object and the attribute, you can see that there is a relation. If there is no relation, you can see them as blank. Sometimes we call it as 0, 0, and this call as 1. So this is all about to indicate the relationship. So now we said concept. What is a concept? In terms of data mining and other computer science literature, we call concept is a cognitive unit of thought or a unit of knowledge. How do I define it? So take an example, I have a fruit. What are the various fruits we have? We have apple, we have banana, somebody may say mango, somebody says grapes, somebody says orange. These are all the various examples of the fruit. But then how do I describe them? I describe them based on their taste, based on their color, based on their shape, based on the way they look. And then imagine if they have seeds inside. So there can be n number of attributes or characteristics that I use to describe the fruit. So I have set of fruits, I have certain characteristics to describe the fruit. Now, both of them I can combine to call it as a concept. So a concept is an entity wherein which I have set of objects and set of attributes or the properties that are describing the objects that I have in the concept. So this is a kind of visualization or for the understanding purpose. So the same thing. Now you can see that objects, apple, banana, mango, which are all fruits, they are all having certain attributes, say taste, color, shape, etc. Okay. Similarly, a concept is constituted by two parts, which is set of objects as well as set of attributes, and there must be having certain relationship. So every object from your set of objects to this concept has either all attributes in B or vice versa. Now we are going to define two terms called extent and as well as intent. We will see what do you mean by extent and intent. Okay. Look at this another diagram wherein which I'm going to say that we have objects, object 1, object 2, object 3. Look at this, object 1 is having attribute 1, attribute 2. Similarly, object 2 is having attribute 3, attribute 4. No, I think object 2 is having only attribute 3. Then object 3 is having attribute 3 and as well as attribute 4. So that means there are certain objects having some properties in the attribute set. having this, how I am going to define my formal concept analysis. Basically, FCA is a mathematical techniques that studies how objects can be hierarchically grouped according to the common attributes. So how I can group my objects that are having common attributes in a hierarchical fashion. And it is basically a tool for data analysis. Similarly, I can perform information retrieval and also do the knowledge discovery task in the databases. And also FCA can be regarded as a clustering method in which the clusters are simultaneously objects and their properties. Okay, so it is also regarded to represent and identify the conceptual structures. So there are various definitions for this. I think I will skip it. As I've said, it's introduced by Professor Billy. And okay, now we'll see what are the three important notions of FCA. Number one, formal context. Number two, formal concept. Number three, formal concept lattice. And of course, there is one more thing called attribute implication. So we can say that there are totally, of course, the literature says three, but for our context, we can take four: formal context, formal concept, and formal concept lattice. So these are all the three important notions from FCA and also attribute implication. Now let us see what is context. Context is a set of objects, set of attributes, and the binary relationship between them is regarded as the context. What is the relation? A relation is saying how a particular object is related to a particular attribute. We will see the derivation operators with an example. We say, imagine we have, this is my set of objects and this is my set of attributes. Now from my total set of objects, I'm taking a subset called A, and I'm also going to define an operator called up operator. This up operator is going to give me from the overall set of attributes subset of elements which are for which this particular objects in A having the relation. That is called A up operator. Similarly, I am going to define another set called B from my attribute set, wherein which the down operator of B is going to give me the objects from my the object set for which I have the relation. And once I have these operators defined, I'm going to define the formal concept. So I'm going to call this AB pair as a formal concept if and only if, number one, if my A up operator is going to give me B, similarly, my B down operator is going to give me A. I think many people might have, not understood or confused or, not able to follow. We will see with the relation. We will see with an example. Consider the problem of classifying plants and animals. Now I have the data set like this. You can look at this, the data set. I have certain rows and columns wherein which I have given the rows some animals. There are some plants. Similarly, there are certain characteristics or the properties. You can see these are all my set of objects, and these are all my set of attributes, which I'm going to call it as M. So if you see here, my context is G, M, I. The I is the relationship between defined between these objects and attributes. So this is my formal context, right? I'm going to call it as a formal context. So when we have seen in the previous slide, this is the formal context. So my data table is regarded as the formal context. So yeah, so this is what actually. Now, if you see A, I'm going to take, which is the subset of G, and I'm going to calculate A up operator, for which I'm going to find all the attributes that are satisfied with A. Now, so take an example. I'm taking A as dog and cat, which is subset of my set of objects, and for which I am finding up operator. That means what are all the attributes common to all these objects? What are the objects I have? Dog and cat. Now dog and cat have what are the common attributes? Lives on land, animal. Similarly, lives on land and lives on land and as well as animal. So these are the common attributes that are common to both these objects. So this is up operator, right? So next, let us take the set B from set of all attributes and trying to calculate the down operator. When I say down operator, I'm going to get the objects from my overall object set. Let us calculate this. So my B is lives on land and animal, and my B down operator, I'm going to get dog and cat. So if I get that, then I'm going to get the formal concept, which is the A up operator, and then the B down operator gives me the formal concept. So the derived concept is, A is equal to dog cat, B is equal to lives on land and animal. This forms my concept. So A comma B is the concept. I hope with this example, those who could not follow with formal definitions could relate and then follow it. How do I going to calculate these concepts from the given data set or given formal context? So we are going to pick a set of objects and derive the attributes. That means the up arrow. And once we have the up arrow calculated, that means B is calculated. What I'm going to do is B down arrow. And once I find it, I'm going to get the formal concept. So this is the derivation operator we have, and to find the formal concepts. Now, let us take the same example once again, so that we will see what we have seen, what is a concept, how a concept is formed, and what not a concept, so that if there is any minor confusion, that goes off. So formal concept corresponded to, now if you see here, a filled rectangle. So that means dog cat I have taken, the common attributes lives on land and animal. And the dual approach, I have taken lives on land and animal, I'm able to find only dog and cat. So this is the concept. Okay. So each part of the determines the other, and hence this forms the concept. Now let us take. So take an example. I have the following pair, wok and potato. So from the set of objects, this is my A. I have taken the attributes lives on land and plant. Okay. Lives on land and plant. So wok and potato lives on land and plant. But if I take lives on land and plant, is it that I am getting wok and potato? Certainly not, because I have another object satisfying or meeting the characteristics called plant lives on land. What is that example? Is the reed. So this do not form the concept. So we have seen example for what forms the concept, and we have seen the example what do not form the concept. So when I take the objects, I'm able to find the common attributes, and the reverse also should be equal. So when I take the attributes, I should have the same set of objects satisfying this. But now if you see here in this particular example, I have one more object satisfying these or having these particular properties called read, not part of my objects set of A. So hence this do not form the concept. This is not a concept. Okay. Now, so you can see that there is a small data table having certain set of objects and set of attributes. Now the point is I have A1 B1, wherein which all x1 to x4, then y3 y4. It is a concept, because we see here when I say y3 y4, when I try to calculate down arrow, what I'm getting is x1 to x4, and hence this is the concept. Like this, we have certain examples. I think I just leave it for your your thought process or to exercise. So the point is that now once I have these concepts identified from the entire formal context, you can see that this is my context. This is my set of concepts that are derived from the given context. Okay. So now you can see here, my first concept is I have taken all objects. Is there any attribute that is satisfying these all objects? Of course, I don't have. So this is a concept. Okay. And similarly, I have no attribute meeting all objects. So it's a concept. Similarly, if you see the last one, you see here all attributes are taken, y1 to y4. Is there any object satisfying all these attributes? Of course, yes. So x1. So you can see that C1 to C6, all these concepts that are derived from the given formal context, they are ordered in a satisfying the relation subconcept and superconcept relation. Okay. Now, if you look at this subconcept and superconcept relation, one particular concept is a subconcept of another concept, provided the object set, first one is subset of the other one, and with regard to the attributes, the first one, the second one is the subset of the first one. Okay. So this is what is the subconcept and superconcept relation. Now, once you have this relation among these concepts, all these concepts that are listed hierarchically, they can be visualized in the form of a lattice structure. So this is what is called concept lattice. So when you define all the concepts from the given context and put these concepts in a graphical representation, they form the concept lattice structure. If you see here, the top node, the topmost node group all objects. So that means the C1 node, you have x1 to x4, and the bottom node groups all attributes. So that means, you can see that y1 to y6. So objects in an extent, okay, the point is this is called extent. In a given concept, the object set is called extent, the attribute set is called intent. I think this is the fundamental, another definition, which few slides back we thought of introducing, and then I just went ahead to try to find an example, but yeah, this is the example. So you can see that in a given concept, the object set is called as extent, the attribute set is called as intent. So again, point is, in this lattice structure, what we say is that the top node of the lattice is called the generalized node, because you see that all objects are given, and the bottom node of the lattice is the specialized node. You have all attributes. This is another example from the available in the standard textbook of FCA, written by Ganter and Willy. You can see that for the given context, all the formal concepts that are derived, and then these concepts are visualized in the form of the lattice structure. Okay. So now the point is, how do I calculate the concepts from the given lattice structure? There are several algorithms. The popular one is the upper neighbor algorithm, using which generally we calculate the concepts. So you can see that there is a context given, and the algorithm goes in this 8-step manner. You can see that first what we do is we take the set X, which is the set X is about all the objects, and what we are going to do is first we determine all upper neighbors of the least concept. What is the least concept? We all know that the least concept is the your 1, 2, 3, wherein which you have this all attributes. That means 1, 2, 3, and then do we have this is your intent, and extent of this is your x1. This is your least concept. So we take all attributes first, and then we will find, is there any objects satisfying this? Of course, in this particular example, we have x1. So we take that as the least concept, and then try to find the upper neighbors. So from C6, we calculate C4, C5, and then goes on. So this is the algorithm for that. I think, I leave it for, this is step-by-step process. Those who are really interested to generate the concepts, one can do this step by step, and it's a self-explanatory, wherein which we have taken this, the least concept X1, 1, 2, 3. And then once we have done, what we are going to do is we're going to take a min, which is X minus A. Okay, so now the A is your X1, and we are going to calculate min. As per this min, X minus A is X2, X3, X4. Okay, so X1 is removed from X1 to X4. So my min is X2, X3, X4, and the step 2 says of the algorithm says neighbors is 0, and then we are going to run the loop from 3 to 8, and then try to find the concepts that are above the C6. So immediate upper neighbors C4, C5, and then the algorithm goes to calculate these concepts. So we have the algorithms for this. And we have, in the beginning, we also said when you do the analysis, number one, we get the set of concepts. Number two, we visualize these concepts in the form of a lattice structure. Number three, there is one more output that is coming from the FCA, which is called an attribute implication rule. So what is an implication rule? An implication is generally represented in the form of A implies B, which is coming from both A and B are coming from set of attributes that are held in a given formal context. And remember, this holds if and only if A down arrow, that means extent, is the subset of B down arrow, which is again the extent of this particular one. So we can see that if every object that has all attributes in A also has all attributes in B. What do you mean by that? So you can see that we have already discussed about the formal context. We have already discussed the set of concepts. Now we are going to talk about the implications or the rules. So now you can see that a rule says Y4 implies Y3. So you can see that wherever you have Y4 coming from, wherever you have Y4, that also has Y3. And how many such rules we have? The count, it is 4. Similarly, wherever Y3, Y4, it is Y2. Wherever Y3 is there, it is Y4. So you have the rule that says Y3 implies Y4. Wherever Y3 is there, Y4 is there. You have some rules satisfying the concepts that are satisfying is the 4. So this is the count. So this is called an attribute implication, which is the byproduct of the FCA. Okay, and these rules satisfy certain mathematical properties of reflexivity, transitivity, and augmentation rule. I'm just giving one example wherein which we have taken from one of the research scholar from University of South Africa, which he has presented in his thesis about 3 diseases: the tuberculosis, hypertension, and the blood pressure. He has done a sample survey and which he has collected from the South Africa, and you can see that there are certain expert rules given for tuberculosis. So the expert rule says when there are certain symptoms like persistent cough, bloody sputum, weight loss, this leads to the TB. Like this, there are certain symptoms, and under what conditions the TB would occur. Now, what the scholar has, his name is Vincent Horner. He actually did in his thesis was he actually analyzed that entire the TB data, the hypertension data, then hypertension, TB, then blood pressure data using FCA, and identified what are all the rules that are coming from the concepts. Are those rules are adding any value to it? So he identified that the implications, attribute implications that are produced from the FCA. Of course, the FCA he has done over the patient's data that he has collected from different, the health centers of across the South Africa, and over that particular data set, he has done the analysis, applied the FCA, and he identified that the rules or the attribute implications produced by the FCA is satisfying expert rules. And on top of that, the FCA is also produced certain rules which are not part of the expert rules. So that means FCA rules produced from FCA are adding more knowledge to the diagnosis. So that's what was the inference given by this scientist, or the Vincent Harner. So what we have done, that was when we started our work, in 2007 or 8, when I was doing my PhD, that was the context. These are all the things that I've learned. Subsequently, I have formulated my research problem under the guidance of Srinivas sir is about, number one, how for a larger data sets, or when I have a larger formal context, how my lattice structure can be derived. Especially for that purpose, we need to derive the concepts. How do I derive? Is there any way that we can perform some analysis? So in that regard, we have done taken a benchmarking work from researchers who has worked on using the singular value decomposition on the formal context. We have taken that and then tried to apply a better machine learning model, which is the fuzzy k-means clustering model that was published in Expert Systems with Application in the year 2010. So we have done that, and by deriving the smaller concept lattice by inducing equivalence relations between the concepts, we could identify a smaller concept lattice, which was published in the Expert Systems with Application in 2010. In fact, this has formed the as a basis for my subsequent work. And as I've mentioned, this particular approach, what we have proposed, in fact, that was applied and tested on the data set given by the Vincent Harner on the Medical Research Council of South Africa data set, and experiments we have conducted with the help of FCA-based SVD and FCA-based FKM, and we have done different analysis. So these are all the various symptoms that are there in the this one, and then these are all the various expert rules for tuberculosis, and this is the formal context. The samples formal context is this one, and subsequently you can see that wherever these are all patients and their symptoms, and the final one is whether the TB is diagnosed or not. The patient was identified as having TB or not. So this was the data set, and this is the lattice structure. And of course, don't worry, the visualization of this structure I will show you with a different with a toolkit that what we have used. That demonstration I will show. And these are all the various rules that are produced from FCA, as I've already mentioned. Of course, we have varied. We have done the experiments with SVD with the varying different heuristics of the SVD parameters. We have checked. And all these results, which I will not narrate now, but the point I wish to inform is that we could analyze all this, the application of FCA and applying FCA, fuzzy k-means clustering based FCA, deriving the implication rules over the reduced data. We have verified that with regard to the metrics such as specificity and sensitivity, wherein which the specificity is indicating about the true negatives that are correctly classified. Similarly, the sensitivity is talking about the true positives that are correctly classified. I wish to inform that the analysis would identify that the specificity and sensitivity of the analysis is meeting the required FCA's rules. That's what actually our analysis, and it got published on the various articles. So you can see that the analysis was published in 2010 on a different journal called Journal of Biological Systems. And also we have done with the different technique for reducing the dimensionality, which is called random productions. That was also published in International Journal of Applied Mathematics and Computer Science. Of course, these journals on those days were having impact factor of 1.2, 1.3. And then this is another article which was published on using the fuzzy clustering based formal concept analysis for association rule meaning applied artificial intelligence. Then this analysis was done using non-negative matrix factorization. So the point is that all this analysis was done by viewing formal context as a typical data matrix and performing matrix transformations on the data and applying the FCA on the transformed matrix and identifying the knowledge derived from the transformed formal context and measuring that values that have come against specificity, sensitivity, and then whether those rules are meeting the expert rules or not. So this was the analysis that was carried out. And so once we have done that, subsequently we have also found that these particular lattice structure, we can also find it in the security literature, especially in defining the access control policies, the role-based access control, designing the role-based access control. So this particular article was published in Wiley Journal on Security Analysis in the year 2012, which is about designing the role-based access control policies using the formal concept analysis. Subsequently, my scholar, Mr. Dr. S. Chandramoulishwaran, he actually extended that particular work by taking triadic formal concept analysis. So the triadic formal concept analysis here is about, now so far we have looked at the formal context as set of objects, then set of attributes. Now there is another dimension to it called set of conditions, right? So that means there is one more dimension that is got added to this, not only objects, not only attributes. So objects satisfying an attribute under a given particular condition. So that is called triadic formal concept analysis. So, again, that was proposed in the literature. So what we have done is that we have designed the role-based access control policy using the triadic concept analysis, wherein which we have the set of roles that are to be defined on certain data items, providing certain conditions are met. So how to define such access control policies using the triadic concept analysis? That was the work that was carried out by my research scholar, now Dr. Chandramoulishwaran. And subsequently, he again went into the different the different dimension of the formal concept analysis called three-way formal concept analysis. So the three-way formal concept analysis comes into picture when we are trying to analyze not only the objects that are having the relation with the attributes, but also about the objects that are not having the relations with the attributes. So that means so far we were talking about objects having relation. This is the three-way concept analysis is about objects that do not have the attribute relations. How do we take the meaning out of it? So that was the one article which was on the direction of the access control policies. This was published in the International Journal of Machine Learning and Cybernetics of Springer. Both the journals are from Springer. This is one of our review article which is available for to download. It's a comprehensive survey. Of course, there are several review articles related to formal concept analysis published by various scientists. So this is one of our survey. In fact, the lead author is Dr. Prem Kumar Singh, who was my the research fellow in my National Board of Higher Mathematics project, and subsequently he took his PhD degree under this fuzzy formal concept analysis theory, and currently is working in VIT AP University. And this was the article on survey, which is available open access under the International Journal of Applied Mathematics and Computer Science. And in fact, the work done by Prem Singh was somewhat interesting and got published in one of the premier journal of Elsevier. Information sciences having a high impact factor. Now it is around above 7 point or 8 point above. When it was published, it is at 4.5. It is one of the tough journal to get things done. So in this particular article, we have addressed certain interesting questions formulated under the NBHM project. Is about how to represent the bipolar information, that too in the fuzzy formal context, and then how to investigate the formal context concepts that are hidden in the bipolar fuzzy context. So now you can see that the data formal context, that whatever we have taken, it's got extended to fuzzy context. That means, you know, you have the fuzzy relation that is on one side, and then further it got extended to bipolar fuzzy context. So how do you define the fuzzy formal concepts out of it, and then how do we visualize these concepts that are coming from the fuzzy formal concept analysis? How do we find the attribute implications from these bipolar context? So that was the investigation that was carried out, and for that several algorithms were proposed. And this article is dealing with that, and those who are really interested can have a look at it. And of course, subsequently there are several articles that have come under this particular formal context, where in which the context is talking about the data in the fuzzy setting and performing the formal concept analysis. Of course, you know, we have done the analysis with different metrics, different techniques. So we have used the information theoretic measures such as Shannon entropy and all that. For number one, our work was focusing on reducing the the lattice structure by reducing the dimensions of the data. Number one. Number two, about simplifying the lattice structure. Number two was identifying the attribute implications. That was the overall view. So again, this was another article in the interval valued fuzzy formal concept lattice. How do we represent the knowledge? So that was again another work by Prem Singh, which was published in the Soft Computing Journal of Springer. This was one industrial application which we have applied the concept lattice for industrial process. This work was carried out by my collaborators in the Brazil, Sergio Dias. In fact, now he is working as a data scientist in Brazil itself. Again, another is my scholar, Dr. Sumangali. She also worked on the FCA and using the concept compression, concept lattice reduction, and all that. This is another interesting work which my student Aishwarya, in fact, she worked under her, this work was carried out by her for her MS software engineering, as a MS software engineering project, which is a 5-year integrated program project, wherein which we were trying to model the cognitive functionalities of bidirectional associative memory. Those who are familiar with the neural network literature, there is a neural network model called bidirectional associative memory. So this particular work was focused on how do we model those functionalities using the FCA, especially storing and recalling the memory patterns. So this was published in Biologically Inspired Cognitive Architectures journal. Unfortunately, now this journal is seized. No more it is in publishing. But the point is, this article is available online. Again, it's there in the Elsevier. The journal is no more publishing the articles. So this work was done by Radhika Shivhare, who was my scholar in one of the research project, in which she was connecting the FCA theory with cognitive informatics. See, those who are really interested in this domain, There is a professor in Canada called Dr. Wang, who has introduced the theory called cognitive informatics. Extensive work he has done. There were several books he has published, in which he has proposed several algebraic structures to define cognitive relations, cognitive informatics. So we were actually trying to connect what we have done with regard to FCA and with the cognitive informatics theory that was proposed by Dr. Wang. So this was the work published under the journal called Cognitive Computing, again an Elsevier journal, now having an impact factor of around 4.5. Again, Radhika has extended the three-way analysis, which in fact I have mentioned about three-way formal concept analysis of some time back, where in which we are going to take not only the objects that are having the attributes in relation, but not having the relation. That also we have taken, and she has actually tried to come out with a approach for cognitive memory functionalities. This work was published in International of Machine Learning and Cybernetics journal. And then Aishwarya, what happened? She joined in my another project for her MTech by research. She has actually tried to bring and understand the quantum aspects in our human consciousness. And for that particular understanding purpose, she has used the three-way FCA, which I was talking about. And this work was published in the Cognitive Computing Springer Journal in 2020. Now, so far, whatever I spoke is all about the generating the concepts, generating the lattice structure, deriving the attribute implications, and also trying to minimize the whole computational process. But now, having said that, we have the various big data frameworks coming from software libraries and also the hardware accelerators such as GPUs. We were actually exploring whether is this minimization problem still holds. Why not we scale it up rather than trying to minimize? So we were trying to work on scalable formal concept analysis, where in which we were trying to propose some of the algorithms that are suitable for the current big data frameworks, which includes Apache Spark and Hadoop, and etc. So all the algorithms that what we have generated in classical sense for both classical FCA. Of course, we were trying to explore for fuzzy, but we could not. But for three-way FCA, all that we could migrate it to the MapReduce, the Apache Spark framework, and these are all the algorithms. This was all done by my current student Raghavendra, who is actually is on the submission process of his thesis. So these are all the various programming models which are all done under Apache Spark, MapReduce frameworks, and all this were again tested under different data sets that are available in the open domain. Again, the algorithms are tested against their various metrics, and these works are also published in various reputed international journals, which is Ambient Intelligence and Humanizer, Journal of Ambient Intelligence and Humanizer Computing. This is about implication-based generation. Again, the algorithm, if you notice, the proposed algorithms, number one, they are rule-based, and we could propose the parallel versions of it, and we could also show the fault tolerance of it. The computational time is in polynomial, and we are able to support the large data sets. And in addition to that, these algorithms, whatever that are proposed now, they support the streaming data also. So in that way, in one way that, whatever that work, earlier work we have done in trying to minimize the complexity and all, the Raghavendra, in fact, is done reverse by scaling it up. So in that way, it's a very good contribution from Raghavendra. And this is the recent publication which Raghavendra has published in Journal of Parallel and Distributed Computing, wherein which the three-way formal concept analysis was taken into the distributed environment of the Spark. So this got published after almost 1 year, 8 months of review out of struggle. In fact, I'm proud to say that he said he will submit thesis only once this paper got accepted, though he has actually got papers which were meeting the criteria of submitting the PhD. But he said that, sir, I'll submit my thesis only if this paper comes, because this is one of the flagship chapter that would be for his thesis. So he wanted that this should be better. I think that's the actually passion that he was having. But 1 year 8 months he sacrificed it for that. But now with smiling face he is submitting his thesis. So point is, our current focus is on this. The whole team is focused on this. So number one, on security, we were focusing on the encrypted communications and privacy, and trying to find the meaning out of the encrypted communication. And on the machine learning models, we were trying to work on explainable federated models, trying to apply to various domains such as healthcare. We are trying to venture into quantum computing, QML, cognition, and application. As I said, we are trying. Rest depends upon the blessings of funding agencies. If they give some fund, there will be some scholars who will be showing some interest. So these are all my scholars. I'm thankful to all of them. The Jinhaili from Kunming University, Sergio from Brazil, Martin from Czech, Prem Sumangali and Chandramolleshwaran has taken their PhD degrees from the work what I have shown, and Radhika, Aishwarya have worked under the projects, and Raghavendra is about to become the doctorate. So we invite all the interested, curious, passionate scholars who get interested about these domains can connect with us. The entire source code, actually, what Raghavendra has done, we could keep it in the GitHub portal, and then it is available at free. Those who are interested can download that code and then play with it. Now, with this, I conclude. But the point is, I am going back to I'm going to the tool which I'm going to show. Just give me a moment. I will share that screen. Is that Concept Explorer screen is visible? Hello.
Yes, sir. It is visible, sir.
Okay. Yes, sir. Thank you, sir. So this is the Concept Explorer tool, which is, again, it is freely available. Those who are interested, they can download this tool from internet. You can just Google it as Concept Explorer or ConEXP. Which you can what you can it's just play. You can just play with it. Even any beginner can just play with it. You can just see that you go add to the menu, say new context. Yeah. So Amma Shahinaz, can you please mute? Amma Shahinaz Begum. Yes, thank you. So you can see that this is how the tool interface looks, and I'm thankful really to this team who has actually created this tool. In fact, this has helped our research a lot, and those who are really interested, you can play with it. You can see that you can define the number of objects. You can say that I want, say, 5 objects, and say you want to you can have, say, 5 attributes. You can tell what is the count of object and what is the count that you say, and then also you can define now the relation. So take an example. I feel that object 1 has this particular attribute. Okay, and remember, you can even name the object, say apple. You remember that context I have shown, apple. Okay, mango, then banana, like that. You name certain objects. Okay, and then you say their properties, with regard to taste, with regard to color, like this. You actually give the attributes. It's easy to play, and only thing is we should sit and play. have some patience to invest some time. Color, then you say taste, color, seeds, yeah, like this. You say okay. Once it is done, okay, color, okay. So once it is done, you can see that there are certain options for us to build lattice, that constructs the lattice with objects, with the concepts. So you can see what are all the statistics. You can see the total concepts coming from that sample context. What I just gave a random context. Concept count is 7. The number of edges between these is 9. Height is 3. Like that. Similarly, you can. Then interesting aspect is that you can calculate the attribute implications and then association rules from this particular tool. These are all association rules that are coming. So you can say that taste, color, seed. Similarly, taste, seeds, and of course, what I have given is a random context. I will show you with an example, with a data set. So this is about the association rules that comes. And another interesting aspect is that you can start exploring the attributes. So I suggest that those who are really interested can try this option. Interestingly, the tool asks you after exploring the context certain questions. You see the question: is it true that when the object has certain attributes, it also has certain attributes? Now it is our turn to say is yes or no. If it is yes or no, if you say yes, that means you are saying it's observation from the data. Imagine you say no, it asks you to enter a counter example for that. Okay, so it asks you to provide a counter example. Otherwise, you accept the rule that it has identified. So in that way, the tool is little interesting. Okay, now I'll show you the. So in that way, through attribute exploration, you can build actually the knowledge. So people who are working in ontology also, they can. So I'll show you the original data. If you see here, this is the, okay, I'll show the tuberculosis data. Yeah, okay. So this is the tuberculosis data, which the sample data that Vincent Horner has provided is in his thesis. You can see that there are about 21 patients, and there are the various symptoms of these patients. You can see the last one is the tuberculosis. Whether it is present or not. Now this is the lattice line diagram for it. That means you can see all the concepts derived and then the lattice diagram. And of course, if you see this lattice diagram, it looks little messy. So we were actually trying, in the sense that it is trying to find all the concepts. So you can actually zoom in. You can take that as an image. You can take that as image, and then you can store it. So scale the picture to get it as an image, and then there are various options. In fact, the tool also has there is a help file, a manual. I suggest that you can take that manual and try to play with it. So these are all the various association rules this particular tool has generated, and you can see that the you can see that look at this association rule. This rule has antecedent and then consequent. So it talk about the count that the antecedent is there, the confidence level, and the support count for the consequent. So those who are interested for association rule mining, they can play with it. And also they can one can you can see the confidence level. You can either minimize it, you can increase it, or you can decrease the confidence level. As I said, it's all depends upon the user choice. So you can increase, either decrease it.
Sir, Ashwini sir, you are muted.
Okay. Yeah.
Sir?
So yeah. So I have you can take any part and you can save it as an image. And also you can say that you want to show the labels for the nodes, you can show the labels. You don't want to show the labels, you can unselect them. Similarly, you can show the labels for objects, and you can do the stability of each of the concept. You can see the definition of stability as per the help manual. So what is the stability of each concept that is produced? So like that, one can play with the this particular tool. Okay, now you can see the context, you can see the line diagram or the concepts that it has generated, and also the association rules that it has come out. And this is the only tool that is there for FCA? Of course not. There are several other tools, but I find that this is somewhat interesting and user friendly. But there are other tools. You can also Google it. Asking for FCA tools. There are tools for of course at a minor level, not this much of user friendly for even fuzzy environment. And there are tools available in the GitHub portal, which those who are really interested, they can play with it. And as I said, there is a help manual. So when you Google it, you get this. Okay, let me show you the help manual also. So you can see that I think all of you are able to see the user guide folder, user guide that I'm. So you can download ConEXP 1.3. This is the. Are you able to see the PDF?
Yes, sir.
Yes. So this is the user guide. Yeah, this is the user guide, 13 pages document. What is the data input that you can give either in the comma separated file format or even the Excel file. Then how you can change the size of context. Then can you compress the view of context, arrow relations. Then subsequently you can also see attribute set reduction, object set reduction. By default, the ConEXP has certain reduction facilities. Wherever the relations are not there, it try to minimize it. Of course, the techniques what we have worked are nothing to do with this. This is what we have done is on top of that. Okay, so how do you explore the line diagram? What are the various visualization modes that we have? Actually, I have just shown only one way, but there are ways in which you can zoom in, zoom out. Then you can show the labels, which I have mentioned. The stability of the concept. How do you define the stability of concept? Then changing the layout of the lattice. So these are all the various things, but coming to the display the lattice statistics about the concept count, edge count, lattice height, then the attribute implications, searching for the association rules, then how to perform attribute exploration. As I've shown, attribute exploration is that when you say perform attribute exploration, it identifies the rules for which the data set is supporting. And when we say that no, that is not the rule, then we have to provide a counter example in the sense that we are increasing the data set size and providing the new knowledge to the system. So yeah, so this is the team that has developed the this particular interesting tool, who worked under Dr. Sergey Obadikov. This tool is really, I felt interesting tool, especially those who are wishing to interested to work on this. Okay. So on top of that, as I said, our source code is available in the GitHub folder of Raghavendra Chundiri GitHub folder. Those who are interested, they can play with it in the three-way formal concept analysis, especially that is for the big data environment. With this, I think I'll conclude my talk. If any questions are there, I am happy to take it up. But all that, again, I have mentioned it in the beginning of the talk, and I wish to conclude my talk also that whatever I could present, the work, either the research work that I presented or the work that was carried out by my scholars, is all just because of the mentoring and guidance that I have received, and which I did was actually I passed it on to my student. So in that way, actually, I am a kind of passing the ball. So all that was done by I know by Srinivas sir molding me to give me an opportunity to. Because of that, I could able to present this talk today. Thank you very much.
Thank you very much, Ashwini Kumar, for your inspiring lecture. You have covered everything, all the developments, and also shown some recent papers published in several notable.
Sir, your voice.
Sir, you're in mute. Sir, unmute yourself.
Sir,
Yeah.
Right.
Participants, if you have any questions, you can just interact with Professor Ashwini Kumar. Sir, your lecture is really inspiring, and you have covered everything in the domain of your work. And you have also shown some quality papers, what you have done, what you have been doing with your team, which will be definitely helpful to our participants. And participants, if you have any questions, please interact with Professor Ashwini Kumar, sir. Stage is thrown open for discussion. Some general questions are there, like can I get slides, notes, and so on? Please don't worry. Whatever that experts share, that will be shared to all the participants. That include your video or audio clips that we are generating. Any technical questions if you have, please interact with Professor.
Okay, so if there are no questions, maybe in the interest of audience, I will ask some questions. I would be happy to see the responses in the chatting window. So can somebody, respond? What are the output that FCA is providing? Can somebody type in, and I'll be happy to see the responses. What is the output that we are deriving from FCA? Can somebody send it in the chat window, or even they can tell that? Okay, so one is concept lattice. What about other?